Hey there again, Pre-Calc students. We're going to continue with our 1.5 graphing of functions. We're going to look at increasing or decreasing behavior. So we're going to look at y equals x cubed or f of x equals x cubed. So we're going to graph that on our calculator. So if I go to y equals, I type in, notice I've kept a lot of other equations in there, but I'm graphing this one right here, y equals x cubed. And so here's my graph. So when I look at this, when you are deciding increasing and decreasing, you have to just do it like you're reading a book. You come from left to right, and if the graph goes up, it's increasing. If the graph goes down, it's decreasing. If it's going straight across, it's constant. So those are your only really three options in terms of increasing and decreasing. We also throw in constant there because the graph could be constant. It could be going straight across. So when I look at this graph, where does it start to increase, decrease, or stay constant? Well, here's the beginning part of the graph. It comes from down this way. So coming from left to right, that graph is increasing. It's going up. As you travel, think of going down like a highway or something. As you go this way, what's the graph doing? It is rising. So we're increasing. So we're increasing. Where does it stop increasing? Well, if we zoom in here, it still is increasing, and then it keeps on going. There may be a point in which it's constant, but normally we don't break it down by 1 point being constant. So this is really an increasing function from left to right. So we're going to write that in interval notation. So if we are increasing at negative infinity, is really where it starts, we have a parenthesis around it. You never put a bracket around infinity or negative infinity. And where does it stop increasing? Well, it doesn't. So that's also infinity. So that's really our increasing. It increases the whole entire time, and then we're going to put that it's increasing. And we can be a little abbreviated here. We're going to say it's increasing. So now we got to graph this one. So x cubed minus 3x. So I'll go to my calculator. Go to y equals. And I've already typed it in. I think I did. Yep, there it is. So I'll turn that graph off, I'll turn this one on, and then we're going to graph it. And so we have this thing. So as I come from left to right, the graph it's going up. It's going to increase. Does it ever stop increasing? Yes. It stops increasing right here. So we need to figure out what this point is. And in the last video, we learned how to find a min or a max. This is a local or relative max point. So we have to find that. So second calc, we're going to find the maximum value there. We need to do our left bound, our right bound, and then our guess. Because that's where this point right here is where it stops. So our maximum is negative 1, 2. So we need to keep that in mind. So when we go to record, it is increasing. And it starts increasing at negative infinity. It increased from way on the left, and it increased. Where did it stop increasing? So you want to record the x value, because it's just like a timeline in history. The increasing stopped at negative 1. It went up to 2, but where did it stop increasing? It stopped increasing at negative 1. So I want to record that point of where it stopped increasing. So it stopped increasing at negative 1. Now, if it were the end of something, or if it were a close point, then we would put a bracket on it. But we're going to put a parenthesis around it, because at that point, it's neither increasing nor decreasing. If I go back to my graph, this point here, any local maxes or mins are considered points that are neither increasing nor decreasing. It's kind of like if you jump up in the air, at some point when you jump up in the air, you stop going up, and right before you start going down, there's like a split second of, you're just free fall. You're almost floating there we don't notice it, but it's when you change direction. So now we got to find this point, because we're going to start to decrease. And where do we stop decreasing is down here. So we increase to here, we're going to decrease to here, and then we're going to increase again. So where did we stop decreasing? Well, I got to find that min point. It's a local min. So I need to go to the left. Again, we're trying to find this point right here. Go to the left, hit enter. Go to the right, hit enter. It doesn't matter how far to the left. You just must be to the left and right of that point. So that's close enough to 1. We're going to call that 1 comma negative 2. We're interested in the x value. So you started to decrease here. You stopped decreasing there. So I come over here to my notes, and I'm decreasing from -1 to 1. And notice, -1 is a shared point between the increasing and decreasing. Technically, -1, nothing is happening at -1. And then we have one last thing on our graph. We're going to increase. And we're going to increase, if you look at the graph again, you're going to increase from where you stop decreasing. So I'm increasing from 1, and then I increase forever thereafter. And so that is my increasing, decreasing. Letter C is a piecewise function. It's going to have 3 different intervals. Okay? Looking at the slopes, you might be able to guess which one is increasing, which one is decreasing, which one is constant. We're actually going to have all 3 here. We're going to have an increasing. We're going to have a decrease. And we're going to have a constant. Not necessarily in the order in which I wrote them. We are going to have all 3. So when I go to graph these, I believe I already typed them in. Yep. So y1, y2, and y3 are the 3 graphs. Again, graphing a piecewise function from our last video becomes a little more problematic. We're going to graph all 3 of them at the same time. So I know that can be a lot of, that might be too much. And if it is, then turn off the other 2. Graph 1 at a time so it's not too much. So here's your first graph, the blue one. We don't want this whole graph. We only want a certain piece. So when I look at the piece that we want, the blue one is x plus 1. We want it from 0 and to the left, less than 0. So if you look at the graph, this is an increasing function. As you go from left to right, it increases. But where do we want it from? We said 0 this way. So this is our increasing function from way over here. We're not going to want this other piece. We're going to have, this graph would have an open circle here and would be shaded this way. We wouldn't count this other part because it's called a piecewise function. So I'm going to be increasing from -infinity to 0. That's where I'm going to stop increasing. Now we go back to our graph. We're going to turn off this one. Again, you can have all 3 of them graphed at the same time, but if it's too much, just graph 1 at a time. So I graph it up. That is a constant function. So there's my constant function. I need to look at the piece, though, that I'm interested in. I'm interested in from 0 to 2. That's where I'm constant. I have a constant function from 0 to 2. So on my graph, I want from here to here. That's what I want. So knowing what my restrictions are, my domain is decreasing from 0 to 2. And now notice what I did. We are including, because we are including 0 as the decreasing. This counts at 0. This counts at 2. We didn't count this function at 0. That's why it has an parenthesis and open circle. So this is also learning how to use interval notation, not just increasing, decreasing, and constant. Oop. And I wrote it in the wrong spot, didn't I? Yes, I did. I gotta try to find a way to erase that, huh? What's the easiest way to do that? Well, we'll just cross out decreasing here. So that's constant. I wrote it in the wrong spot. So there's to fix it. So my last function, if I turn off the other one, turn it on, and you might be able to answer without graphing it, but if you look at, there's what the graph looks like. So your piece that you're interested in is greater than 2. Well, the decreasing, that's a decreasing function, starts at 2, not counting 2, and then it goes forever. And that's based on that piece. So that's increasing, decreasing, constant behavior. Most graphs do not have constants. Some of them do. Horizontal line does. Piecewise functions can have them. There's some other exceptions to that, but most of the time it's either increasing or decreasing. Okay? All right, let's talk about average rate of change. Basically, you got to find the slope. That's what average rate of change means. So let's write this in here. This is slope. And it's not the slope. We already learned about the slope of a straight line. This is the slope of a curve. So it's an average rate of change, meaning the slope is not the same from one point to another. It changes. It's a curve. So we need to find, in order to find slope, it's still, slope is y2 minus y1 over x2 minus x1. Well, we don't have any y values. We've got some x's. Well, we need to find them. So here we have 0, comma something, and -2, comma something. We need to find that something. So plug in 0 into our function. So if I plug in 0, I get 0. That's okay. Plug in -2 into our function. So if I plug in -2, -2 cubed minus 3 times -2. So I believe that is -8. This is +6. So that makes -2. So now we're just going to find our y value. I'm sorry, our slope. So here we're going to take -2 minus 0 over -2 minus 0. And if you do all the math, you get 1. So the average rate of change is 1. All right. So I'll pause the video, let you try letter B. Okay. Hopefully you've had a little bit of time. You can always pause the video some more, but we have some points here again. We're going to figure out our y values. So we got to plug in. I already plugged in 0 into my function. It's 0. If I plug in 1 in here, what do I get? -2. So we're going to find the slope between those 2 points. So we're going to go -2 minus 0 over 1 minus 0. We got -2 over 1 is -2. Okay. Right down here, even, odd, or neither. So what we end up doing for either, odd, and neither is we have to plug in -x everywhere you see an x. You have to evaluate this function. You have to use function notation. Everywhere you see an x, you have to put a -x. And what you're looking for, if nothing changes, it's even. If everything changes, it's odd. And if some things change, it's neither. And when I say some things, I'm talking about the signs. So this is positive and negative. It's still going to end up, the powers are going to be the same thing. But you're trying to evaluate what are the powers. So if I evaluate this, it just becomes -x cubed. And then if I evaluate this, it becomes x. The negatives cancel. So if I look, positive became negative, negative became positive. Both signs changed. This is odd. That's all you're looking to evaluate. In letter B, if I evaluate -x, if I try to evaluate -x, playing tricks on me now. I think we got our technical difficulties worked out. So we're going to plug in -x everywhere you see an x. Apparently I don't have my technical difficulties worked out. Not sure exactly what the technical difficulties were. It's still playing a little bit of tricks on me, but I finally got it to write out a little bit. So I'll explain it a little bit. You got to plug in -x, and then you got to simplify. So you plug in -x, you cube that. It's just -x cubed, it's just not in parentheses. Nothing happened with the -1. So the first term changed and the second term didn't. So that means it's a neither. It's neither odd nor even function. Then this one, you're going to plug in -x again everywhere you see an x. When you square -x, it becomes x squared. So notice nothing changed, so that is why it's even. So when you're trying to do even or odd, you can also graph it and look at it that way. But most of the time, you're going to be asked to do it algebraically, and that's what you want to try to do. All right, let me know if you have any questions.